Okay, hi Zach. I have made the decision, I'll just tell you what I'm doing. I have made the decision to not move on to the next lesson to kind of give you a little bit of a break, but to go all over the problems that you didn't get quite right on lesson number 37. So, I made that decision, and you might be thinking a horrible decision, really. But, just think of it as a little break. I know you're worried about getting behind in math compared to your peers, but I promise you are not. In fact, if you feel like you already know some of this stuff, enjoy it because we are going to go over some pretty difficult concepts coming up. I mean, you're on lesson number 37, but when you go into the 40s, I mean, we're talking about conjunctions and percents that are less than and greater than 100%, adding rational expressions with unequal denominators, all this fun stuff. And then in the 50s, we're going to start graphing. And that's when it really gets very complex very quickly. I promise you, your friends are not doing that. And I also promise you that they're not doing this to the degree that you are doing. Like, they might have been introduced to the topic, but I promise you, if they tried to do your homework, they would really struggle. And I'm not saying that you're better than them or anything, but you're not missing out. That's for sure. You're not missing out. So let's do some of the problems in lesson 37. I do want you to do these with me. I want to see the answers all written out in your folder as I do them, okay? So we're going to start with number 2 on problem set 37. If you want to look at it in your book, it's on page 151. And it's one of those word problems that says, if the product of 3 and a number is increased by 7, the result is 23 greater than the number. And so I noticed that when you wrote out the equation, you actually did this 100% correctly. You just somewhere along the way mixed up how to solve this part of the problem from here on out. So let's just solve it together. So if I were looking at this, I would subtract an n. Let's start there. Okay. And so 3n minus 1n basically is 2n plus 7 equals 23 because these cancel out. Okay. And then I'm going to get rid of that 7 there, subtract 7. And then I'm going to be left with, what's 23 minus 7? I don't know. It's late at night. I don't know. 23 minus 7. Let's figure it out. Okay, it's 16. So 2n, this goes to nothing, equals 16. And then n is, well, actually, let me move this down. I didn't leave myself enough space. Okay, so I'm going to divide by 2 to get rid of that 2. And then n is equal to 8. And so the answer is n is equal to 8. So somewhere along the line there, you made a mistake. And I'm not sure where it was from there on out. It might have been just a positive or negative sign. But anyway, that's the correct answer. Okay, let's move on to number 7. I just put this little guy here to remind you that you are still learning. But I actually want to move him out of the way. How do I do that? Okay, here we go. There, I'm going to move him out of the way. Okay, so number 7 just says, write an inequality that describes this graph. Okay, so here's the graph that they want an inequality for. So you see that there's a line starting at the number 2 and going all the way to infinity that way because it's it goes on forever that way. So we already know that it's going to be something like x is greater than 2. And that you got that far. But I do want you to notice, this is important. Is it an open circle or a closed circle? And in this situation, it's a closed circle. So you must put an equal sign underneath that, or else you don't get it correct. So that's all you did wrong on that one. Okay, Zach, so we are going to move on to number 9. And number 9 just looks awful when you look at it because, oh my heck, you can't get any more negative than that, right? There's negative signs everywhere. There's negatives on the negative signs. Anyway, So we're going to take this one step at a time. And the first negative I'm going to deal with is sort of this exponent one, because as I look at that, I realize that the negative on the exponent means that I'm going to have to take this whole expression, because what's right in front of it? Right in front of it is the parentheses. So I'm going to have to take everything inside the parentheses, move it from the numerator to the denominator, and then I'm going to have to change the sign on the exponent, okay? So what about this negative sign out here? Well, this one, I'm just going to leave it be for a little while. In fact, I am going to draw a finger over it. And it can be any finger. It could be your middle finger. Maybe you hate the negatives that much. But what I'm going to do is draw a finger over for right now and just not deal with it. Okay, so now what do? We move everything inside the parentheses from the top to the bottom. So I'm going to put -2 here. And then I still have this exponent to deal with, so I have to put a squared sign there. And I've changed the sign on the exponent because I moved it from the numerator to the denominator. Okay, so I've got that so far. What's on the top? Well, just nothing. So basically just a 1 on the top. It's 1 over -2 raised to the power of 2. Okay, now I have to deal with this negative over here because I haven't dealt with that one yet. And this negative means the opposite of whatever I get when I do the rest of the problem without the finger, right? So I'm doing the opposite of this, and it doesn't matter. So I have to just bring that negative over here, and it doesn't exactly matter where you put it. You could put it in front of the 1 or in front of the whole thing, but anyway, that's where we're at. So we can simplify this further because this is going to be let's see. This is going to be 1 over -2 times -2 because that's -2 squared. And I can't forget about that negative sign out there. So that simplifies to -2 times -2 is basically 4, a positive 4. But I still have this negative, and so I've got to bring it because it's the opposite of whatever I get. So my final answer is -1 over 4. Okay, let's go on to example number 10 or problem number 10. So because you got both of these wrongs, I think you're just making a mistake in all the negativity there. So maybe use the finger technique, maybe give it the finger. I don't know. Let's try the finger again and see if it works this time. So this negative right here, it's in a weird spot, but you could actually put that anywhere, right? Okay, sorry about that little interruption. I just took a sip of water and aspirated, but I'm fine now. Don't worry. It's not bad. It's not the Rona. Anyway, let's move on to number 10. I do want you to pay a lot of attention to these because whenever you see a lot of negative signs like you do on this one and like you did on number 9, I want you to pay extra special attention because these are the ones that you seem to be missing. And so I think you need to take a little bit more slowly and see what you're doing wrong. So again, this negative sign out there is one that, whoa, I didn't know it would do that. That's crazy. Is one that we can sort of actually ignore for now and put our finger over it. So I'm going to do that. There's my finger. You can decide which finger. And I'm going to deal with the rest of the problem, and then I'm going to realize that the finger means the opposite of whatever I get. And so I'll have to add a negative sign to whatever I get as a final answer. So let's deal with the rest of it. This negative sign I have to deal with right away because that's telling me to move everything in the parentheses from the denominator to the numerator. Okay, so let's do that. And we're going to do -2 squared over 1 now because the exponent changes from a negative to a positive because I changed it from the denominator to the numerator. And putting it over 1 doesn't really change anything, so I could actually just leave that off and it's -2 raised to the 2 power. I'm still going to ignore my finger for now and just deal with it at the end, okay? So let's just deal with this. -2 times -2 And I know that 2 times 2 is 4. And so the negatives don't matter. They're going to turn into a positive. So this is going to be 4. Now I'm going to finally deal with my finger. Okay, so I'm going to remove the finger. Oops. Oh well, it's gone. But I'm going to remember that this is the opposite of whatever I get. So I'm going to make that a negative 4 for my final answer. So that's the answer for 10. Okay, let's move on to number 14. That goes on the next page. So we're on page 152. And it's basically solve this equation. Okay, so here we go. So I'm kind of scanning across the whole equation and seeing if, is there anything that I can combine, or simplify. Let's see what I can do. So the first thing I'm going to do, yeah, I can combine this. Okay, so the first thing I can combine is this and this because they are like terms, because there is an n here and an n here. So if this were like 1n plus 2n, I could just make it 3n. So I'm just going to add those coefficients and combine them. So what do I have for coefficients? Well, I have basically a -1 and a 0.4. So what's -1 plus 0.4? The answer to that is going to be -0.6. Do you see how I did that? Because you start at -1 and you're going to add 0.4 to that, but you're still at -0.6. So with this in mind, this is going to turn these terms into -0.6n. Okay, so hopefully that makes sense because I just combined those together. Okay, now I'm going to write the rest of the equation. Plus 1.8 equals -4.2. Okay, now what they did in the solution in the book is basically get rid of all the decimals. And that's not a bad way to do it. In fact, we could have done that at the beginning. But they chose to do it in this step, and I'm just going to do it the way they did it and just show you that it can be done that way, and it makes it so much easier. What if you take everything in the whole problem and multiply it by 10? So that gets multiplied by 10, that gets multiplied by 10, okay? So that changes the whole problem to something where you move the decimal, right? So you're going to move the decimal to there, move it to there, move it to there. So what you're left with is -6n plus 18 equals -42. Okay, does that make sense? So let's just do it that way and figure it out. So now I'm going to subtract 18 from both sides. Okay, and this cancels out to 0, and I'm left with -6n equals -60. Okay, and then I can just divide by -6. That cancels out. Even the negatives cancel out. The negatives here cancel out too. So I'm left with n is equal to 60 divided by 6, which is 10, and it's a positive 10. Okay, so hopefully as you do that one with me, you figured out what you did wrong. All right, I'm going to go on to 17b. 17 has 3 parts, which I know that you really love that because it turns one problem into 4 problems. So it basically says, what value of x satisfies this equation? All right, so let's solve for x and see if we can figure that out. So I'm going to look across the whole equation first. There's one variable here, and the rest are just, a whole numbers and mixed numbers and fractions. So we should be able to deal with that. So first I'm going to start by trying to isolate the x on one side and putting all the rest of the numbers on the other side. So I'm going to add 2. Okay, so then I'm left with 1/4 x. That cancels out, equals negative 3 plus 2 is going to be negative 1 and 1/4. Okay? And then, let's see. I wonder if we should, let's multiply everything by 4. You know what? Let me do this first. I want to turn this from a mixed fraction to an improper fraction. So to do that, I'm going to do 4 times 1 is 4 plus 1 is 5. So it's 5 over 4, and it's negative. Okay, so I'm going to leave that there and just fill in the rest of the problem. Okay, now what do? I'm going to multiply everything by 4. Okay, so, because you can do that. You can do that, right? So I'm going to multiply all of this by 4 and multiply this by 4 over 1. In fact, I don't like the parentheses. I'm just going to put a dot. Okay, so this and this cancels out. So I'm left with just x is equal to, these 4's cancel out. And so it's just negative 5. And is that the answer? Yes, that's the final answer. Okay, so that's how I did that. All right, let's go on to number 25. 25 is evaluate this expression. And it tells you that they want you to use these, a equals negative 3 and b equals 5 in the equation. Now, the first thing I'm going to do before I plug in any numbers is just simplify this a little bit, because I don't like that exponent of 0. That exponent of 0, that's just 1. And it doesn't matter what number is put in there, it's just 1. So I'm not even going to plug anything in there. That's stupid, right? So I'm going to do a squared minus, and then I'm just going to do a minus ab. Okay, so let's just do that because that's a little easier to me. And then I'm going to move this down so I can see it a little better. So for this a, I'm going to put in negative 3 squared minus, and then I'm going to put in negative 3 minus negative 3 times 5. I guess this should be a bracket. Okay. Now, I don't love this part. That's with the, subtracting, and delete that. Okay, I don't like that part. So let's just clean that up. That part, negative 3 times 5 is negative 15. So I'm just going to change this whole thing. I'm going to erase it and put negative 15. And of course, two negatives together are just going to end up being a positive. So I'm just going to add that instead of subtracting it. And I'm going to simplify that to negative 3 plus 15. And then this becomes an easy problem to simplify inside of these brackets, because it's basically just 15 minus 3, which is 12, right? So inside the brackets, I have 12. Okay, now let's do the rest of the problem. Negative 3 squared is negative 3 times negative 3, and then you have minus 12. So what's negative 3 times negative 3? Well, it's just 9. And then I have 9 minus 12. And so the answer is negative 3. Okay, final answer there. Let's move on to the next one. The next one is similar. It's very similar. It wants us to plug these in. But again, I'm going to try and simplify it first. I don't love that guy, because what the heck is the point of that? P to the 0 is just 1. So let's leave that out completely, and I'm going to plug in the other stuff. So minus negative 3 minus another k, which is negative 3. Then I'm going to do minus, let's move this a little bit. And then inside the parentheses is negative p, which is just the 2, and k squared, which is negative 3 squared. And then there's should be another parentheses, but I'm going to turn it into a bracket. Okay, so this is very similar to the last one. So whatever you're doing to get these wrong, you did it twice in a row. So that's going to be super important to fix. Now, the first thing I'm going to deal with is this, because this is a big hot mess in here, and I need to deal with that bracket. Okay, so let's just deal with what's inside the bracket. And the first thing I'm going to do is take that negative 3 squared. Negative 3 times negative 3 is just positive 9, right? So I'm just going to erase this and make it 9. Okay, now what is 2 times 9? 2 times 9 is 18. And then I have to bring this negative sign down. So I'm going to put negative sign there. And then I'm going to just bring the brackets down. And then I'm going to write the rest of the problem. I guess I'll write it just the way it is. Okay, what a stupid problem. Okay, like how many more negatives can you get? All right, so now that I've solved what's in, let's see. Let's deal with, this is such a big hot mess. Okay, so I think let's get rid of these brackets now, this and this, because you don't really need them there now that you've solved everything inside of it, right? So let's just get rid of that. And I can write this as plus 18 because you have this minus a negative 18, like as if the brackets are not there because they really don't need to be. So a minus a negative 18 turns into plus 18, okay? So this is still a big hot mess. I don't like any of this. So let's do minus a negative 3. This negative sign means the opposite of, and the opposite of negative 3 is going to be a positive 3. And then minus other negative 3 is going to be plus 3, and then plus 18. So I think the answer is 24. Is that right? That's right. Okay, let's move on to 28. That one was really tricky, though. Don't feel bad for not getting that one totally right. 28 is another big hot mess, and it says to simplify. So this is just testing us on the order of operations. This we can get rid of because, well, we can't get rid of it, though. It's just we can change it into a 1. So let's actually get rid of it and change it to a 1. So plus 1 on the top. I wonder if that's the only thing you did wrong. I'm not exactly sure. Let's deal with the bottom first because it looks a little easier to me. 3 minus 5. Well, let's see. Actually, let me do this. Let me give myself a little more room. I hope you're doing this on your iPad, not your phone, so you can see all this tiny stuff I'm doing because your math is so complicated. So let's deal with the bottom. So if I'm dealing with the bottom, I'm just going to copy that negative 2, and then 3 minus 5 is also a negative 2. Okay, now let's deal with the top. Let's do inside these parentheses first. Negative 3 plus 7 is a positive 4, okay? But because of this negative sign, it's the opposite of that. So it's negative 4 plus 1. Okay, now I can simplify that. So on the numerator here, I have negative 4 plus 1. Negative 4 plus 1 is negative 3. And now I'm looking at the bottom over here, negative 2 times negative 2. Well, I know 2 times 2 is 4, and 2 negatives make a positive, so it's just going to be positive 4. Now, when you have a negative and a positive, the answer is going to be a negative number. So the answer is negative 3/4. And that is the final answer. Let's see if I got it right. It's number 28. Yes, that is correct. Okay. Oh, we both still have a lot to learn, Zach. So good job. Keep up the good work. Love ya. I hope you tolerated this lesson at least. It probably wasn't the funnest thing in the world, but at least you are getting better and better every day. Okay, love ya. Bye.